Isang mapagpalang araw, my dear students. Ngayong araw na to, ngayong oras na to, yung ating video lesson is about limiting excess reactants and percent yield. Ano ba yung mga yun? Okay? So ano ba yung specific objectives natin? Number one is to be able to define the limiting reactant, the excess reactant, theoretical yield, and percent yield. We would also be able to determine the limiting reactant, excess reactant, and percent yield, and finally, solve problems involving those terms which I mentioned earlier. Okay? So ano-ano ba ibig sabihin ng mga terms na yun? So ang limiting reactant determines or limits the amount of product which may be formed or produced in a reaction. On the other hand, the excess reactant remains partially unchanged after the completion of the reaction. The theoretical yield is the maximum amount of the product which can be formed. Now, we use the limiting reactant when we compute or we calculate the theoretical yield. And finally, the percent yield is the ratio between the actual yield and the theoretical yield, which is times 100%. Okay? So, how do we find the limiting reactant and the theoretical yield? So, it's actually a process. So, I have outlined the steps dahil na-proseso siya. May mga steps tayong sinusunod. So, I have outlined here four steps. Number one is to find the number of moles of each reactant present in the reaction. Number two, calculate the number of moles of product formed from each mole of the reactants. Number three is to identify the reactant giving the smaller number of moles of product. Ibig sabihin yung reactant na makakapag-produce ng mas konting product, no? Bakit natin kailangang i-identify yon? Kasi yun yung ating limiting reactant. Okay? Then finally, calculate the grams of product produced by the limiting reactant or limiting reagent. Meaning, we have to compute for the mass of the product produced by the limiting reagent. Kasi, di ba sinabi nga natin, yun yung mas mababa. So, yung mass ng product na mapoproduce, yun mismo yung theoretical yield. Okay, so let us try to use the steps mentioned earlier in this problem. Consider the reaction. 2 moles of SB in the solid state plus 3 moles of iodine also in the solid state will produce 2 moles of SbI3 in the solid state as well. We are asked to determine the limiting reactant and the theoretical yield when, letter A, we mix 1.2 moles of SB and 2.4 moles of iodine. And letter B, we mix 1.2 grams of SB and 2.4 grams of iodine. So kanina moles, ngayon grams, no? So number of moles tapos naging mass. Okay, so we rewrite the balance equation. We are given the number of moles of SB, which is 1.2 mole, and the number of moles of iodine, which is 2.4 moles. No? We are required to solve for the limiting reactant and the theoretical yield. So, as a solution, solving for the limiting reactant, so we need to solve for the number of moles of product which is SbI3 in this particular problem. So we have 2 reactants. We first use the first reactant which is SB. No? So the relationship between SB and SbI3. So we have 2 SB is to 2 SbI3. There is a 1-to-1 relationship. No? So number of moles of SbI3 is equal to the number of moles of SB times 2 SbI3 upon 2 SB, so ratio and proportion lang. Substituting the given value, we have 1.20 moles of SB times 2 moles of SbI3 upon 2 moles of SB. So we have 1.2 moles of SbI3 produced from 1.2 moles of SB. Okay. Now when we use iodine, so the number of moles of product SbI3 produced will be equal to the number of moles of iodine times the ratio 2 moles of SbI3 is to 3 moles of iodine. Again, we got that relationship from the balance equation. So substituting the given value, we have 2.4 moles of iodine times 2 moles of SbI3 upon 3 moles of iodine. That is equal to 1.6 moles of SbI3. And then we have to compare the two values. No? Note that this is obviously lesser. Okay? So the lesser product, the lesser amount of product will be produced with Sb. And therefore, Sb, since it yielded the smaller amount of product, Sb is the limiting reactant. For letter B, we are given the mass of Sb, 1.2 grams, and the mass of iodine, 2.4 grams. So basically, we use the same formula. No? So finding the number of moles of SbI3, that's equal to the number of moles of Sb times the ratio 2 SbI3 upon 2 Sb. But instead of the number of moles of Sb, we are given the mass. No? Recall that the number of moles is the ratio between mass and molecular weight. And therefore, we can solve for the number of moles by dividing mass by the molecular weight. So, yung binigay sa ating mass ay 1.2 grams divided by the atomic weight of Sb, which is 121.76 gram per mole, times the ratio 2 SbI3 upon 2 Sb. So that is 9.86 times 10 to the negative 3 moles. Now, if we use iodine, we use the same formula. The number of moles of SbI3 produced will be equal to the number of moles of iodine times the ratio 2 SbI3 upon 3 iodine. So the number of moles of iodine will be equal to the mass of iodine divided by the molecular weight of iodine. So that's 2.4 grams divided by this, no? Bakit may 2? Kasi we have 2 atoms of iodine. The atomic weight of iodine is 126.9 times 2 gram per mole. So that we multiply that by the ratio 2 SbI3 upon 3 I2. So the number of moles of SbI3 produced when we use iodine is 6.3 times 10 to the negative 3 moles. And then finally, we again compare the values. And obviously, 6.3 times 10 to the negative 3 moles is lesser. Kailan nangyari yon? When we use iodine. And therefore, iodine in this case is the limiting reactant. Iodine is the limiting reactant. All right, solving for the theoretical yield, no, we use the limiting reactant. No? So the theoretical yield is simply the mass of SbI3 produced by the limiting reactant. So yung theoretical yield natin kanina for letter A ay when we use Sb. So we produce 1.2 moles of SbI3 times the molecular weight of SbI3, 502.46 gram per mole. So ang theoretical yield natin for letter A ay 602.95 grams. For letter B, kailan naman nangyari to? So ang limiting reactant natin dito ay yung iodine, no? Where we produce 6.3 times 10 to the negative 3 moles of the product SbI3. So multiplying this value again with the molecular weight of SbI3, which is 502.46 gram per mole, the theoretical yield this time is 3.165 grams. Okay? Example number 2, if 2 grams of magnesium rebond is placed in 10 grams of HCl, letter A, which is the limiting reagent? Letter B, how many grams of magnesium chloride will be produced? Letter C, how many grams of the excess reactant is unreacted? And finally, letter D, if 5 grams of magnesium chloride is actually obtained, calculate the percent yield. So, ano ulit yung unang gagawin? Yung number of moles ng mga reactants since ang given ay mass ng reactants. Okay? So, here's the balance equation. 1 mole of magnesium plus 2 moles of HCl will produce 1 mole of magnesium chloride plus 1 mole of hydrogen gas. Solving for the limiting reactant, so that is the number of moles of magnesium chloride, which is the product, using the first reactant, which is magnesium. So the number of moles of magnesium chloride is equal to the number of moles of magnesium times the ratio. 1 mole of magnesium chloride is equal to 1 mole of magnesium. Substituting the given value, 2 grams of magnesium divided by the atomic weight, which is 24.3 gram per mole, times the ratio 1:1. So we have 0.082 mole of magnesium chloride produced. Now, when we use HCl, solving for the amount of substance, no, amount of magnesium chloride produced from that amount of HCl, so that's number of moles of HCl times the ratio 1 mole of magnesium chloride is to 2 moles of HCl. So substituting the given value, so we have 10 grams of HCl divided by the molecular weight of HCl, 36.5 gram per mole, times the ratio 1 magnesium chloride is to HCl, na galing na naman sa balance equation. Okay? So we have 0.137 mole. Obviously, the first amount is lower, and therefore, kailan yan nangyari? When we use magnesium. Therefore, magnesium is the limiting reactant. At pag nag-solve tayo mamaya ng theoretical yield, yung mass ng magnesium chloride na mapoproduce using magnesium ang ating gagamitin, yung 0.082. Okay? So, ito na yon. Yung theoretical yield, ito na yung nakuha natin kanina na 0.082 mole para na yung mass. Paano natin makukuha? I-multiply lang natin yan sa molecular weight ng magnesium chloride, which is 95.2 gram per mole. And therefore, the theoretical yield is 7.81 grams. No? Ano nga ulit yun? Yung mass ng product, which in this case is magnesium chloride, no? Na mapoproduce. Kanina na-solve natin yun. Mangyayari yon kung ang gagamitin natin ay magnesium. Mas mababa yung amount ng product na mapoproduce. So, imumultiply lang natin sa molecular weight ng product magnesium chloride. So, again, the theoretical yield is 7.81 grams. Kanina sa problem, binigay yung actual yield na 5 grams. So, alam na natin kung paano ang gagawin natin to get the percent yield. But first, we have to solve for the mass of hydrochloric acid which remains unreacted, remain unreacted in solution. Paano natin makukuha yung mass ng HCl na unreacted? So we have to simply subtract the mass of HCl which reacted from the mass of HCl initially present. Paano natin isosolve yung mass ng HCl which reacted, completely reacted in the solution, in the reaction rather. Equivalent yon doon sa amount ng magnesium na nagamit. Ilan ba yung nagamit kanina? 2 grams. Kasi siya yung limiting reactant, diba yung magnesium. Ibig sabihin, lahat ng magnesium na present mayu-use up sa reaction. So parang stoichiometry ulit, kung yung 2 grams ng magnesium mayu-use up, ilan ang equivalent amount ng hydrochloric acid na kailangan natin na mag-react sa 2 grams na yun. Ito yun yung hinahanap natin. So the mass of HCl which completely reacted is equal to the number of moles of magnesium times the ratio 2 moles of HCl is to 1 mole of magnesium. Galing na naman yan sa balance equation times 36.5 grams. Wala yung cursor. Where 36.5 grams per mole is the molecular weight of HCl. So substituting, so the number of moles of magnesium is 2 grams upon the atomic weight of magnesium, 24.3 grams per mole, times the ratio 2:1 times 36.5 grams. That is 6.0 grams. And therefore, the amount of HCl which remains in solution after the completion of the reaction is 10.0 grams. So that's the amount of HCl initially present minus the amount which reacted, no? So that is 6.0 gram. And therefore, the mass of HCl which remains unreacted is 4.0 grams. So wala na dapat tong HCl initial na to. Dito yan, no? 10 grams minus 6. So just don't mind this HCl initial. I'll just remove this when I give you the PowerPoint. Okay. For letter D, percent yield. So this is simply the ratio between the actual yield and the percent yield times 100%. Yung actual yield natin ay 5 grams given yan sa problem kanina. Tapos yung theoretical yield natin, na-solve natin from letter B, 7.81 grams. So times 100%. So that's 64.02%. Mataas na yan. No? So, okay, mataas na yan. Okay, so as your exercise, I'd like you to solve this problem. And then this one. Okay, so you have 2 items to work on as your practice. So thank you for listening. I hope na-enjoy kayo sa lesson as much as I did. Exciting. So in the meantime, class, you stay safe and you stay healthy. See you when I see you, class. Bye for now.